Alright, this is a quick video on using the graphing calculator to find a line of best fit. So here I've got a problem, activity 1, it's called football across the stadium, and we have data that's given to us. And what this data is, and it's not very explanatory in the problem, but it is a time measurement and then the height of a football that's been thrown or kicked or whatever, and it continues on. And so what we're going to do is we want to analyze this data. And I might look for, if you were doing this thing as a real problem, you don't know right away to go to your graphing calculator, but you might look for differences in height measurements to see if there's some consistency there. You might look at ratios of one height to the next to see if it's some sort of geometric growth or pattern. But the best thing to do when you have a bunch of data, depending on the problem, in this case it's asking us to make a scatter plot, so it kind of leads us to do what we are about to do. So here's my home screen, and I'm going to do one thing really quick. Now you shouldn't have to do this except for the one time. I'm going to my catalog, so I hit second catalog above the 0. I'm going to jump to the D's, and I'm going to make sure that my diagnostics are on, so I choose that and I hit enter, and now it's done. So diagnostics are on. That's just going to help me decide if I have a good curve fit. Now, regardless of what the problem is, if you have data that you want to graph on the TI calculators, you hit the stat button. And under stat, we are going to choose number 1, edit, because that's where your lists are. We have list 1, 2, and 3. And there's more lists in there. But ideally you want to put your X data in L1 and your Y data in L2. In this case, the height is dependent upon how much time has gone by. And so time is going to be my independent variable, that's my X value, and height will be my Y value, or dependent variable. And so I'm just going to enter these data points, 0.2, 0.6, etc. I wish I could speed all this up for you, but if you're doing this on your calculator at home, this will give you time to also enter your points. Now remember, if you're taking the park test, you will have a calculator that has the functionality of pretty much what you see on the screen here. In fact, I think it's one of the TI models. I think it's the TI-84, so we just like this. Here's my first set of points. I'll go to L2 for my Y values, 92, 110, 130, 134, 142, 144, 140, it's going back down, 132, 112, 90, and 44. And then I always like to, after I've done my list, I like to double check and make sure they're the same length, otherwise you get what's called a dimension mismatch. Their lengths of list 1 and list 2 aren't the same, so you're going to verify it that you think you have it right. Okay, so there's their data. It hasn't done anything. We haven't done anything so far except for just enter this stuff straight into the calculator. But what we want to do is create this scatter plot. That's in number 2 here. And so to do that, we go up here where it says stat plot. We just use stat to enter our data. Now we use stat plot to graph our data or to plot it. So I hit second and then Y equals, which pulls up my stat plots. I have plots 1, 2, and 3. They're all off right now. I just need to turn one of these on. So I'll turn on plot number 1. I'm going to choose the first one, which is the scatter plot. I don't want it connected with lines, and I don't want a histogram. Right here it says where's my X list, and I already said I tried to put them in L1, which I did, and my Y list, which I put in L2. Then I get to pick the mark that I want to graph it with, and generally the box is the best one. And so I have everything in there, and I've turned on my plots. I just have to tell it how to show it. And I'm going to hit zoom, And I'm going to scroll down, or you can memorize it, zoom 9, zoom stat. And so there's my points. And I've done exactly what they asked for. Look at the scatter plot of the data on a calculator. Discuss the appropriate window and meaning of independent and dependent variables. In general, the independent ones are always on the x-axis, but they're the ones that we don't have control over. In this case, it's time, just keeps ticking by. Now, we don't have control over height either. However, height is responding to how gravity's pulling it down and how much time has gone by. So the height is the dependent one, and the time is the independent one. As far as the window goes, we can look at the window if we want to. X min, they put it, when we hit zoom stat, automatically put it at negative 0.23. I don't know why it chose that value. My x values right here, it starts at 0.2, so negative 0.23 must have given it some sort of symmetry or something. Really, we could start our x at 0 because we don't care about negative time, really. X max, the biggest value we go to is 4.5, so it's scaled it to 4.93. X scale is just, we're going to count by ones. The minimum y value, it starts at 27. Ours starts at 92, but goes down to 44, so it chose that for us. Y max, 161, that's fine. That's above the highest point we have. In general, you don't have to mess with this screen, but sometimes you do. So let's go back to our graph, see if it's adjusted it a little bit. Not even noticeable. Now, the next step is look at the animation that gives an illustration of the meaning of the data. This is where you'd watch a video that shows the football being thrown. And the question that we want to answer is, when is the ball 100 feet high? 100 feet, more than 100 feet, 40 feet, etc., etc. I think this might be a little bit different than the worksheet you got, but the first thing we want to do is find the equation. Now, they've given the equation here in number 4. I think this may be the answer page that I'm on, actually. See if I can find your original problem, so you can see exactly what. There we go. There we are. So this is the original problem right here, and that's just the same data. So here's A. I've shown with scatter plot, discussed independent, dependent variable. Now we're going to find our mathematical model. All right. To find a model, what we mean is find an equation that predicts this data set that we have. To do that, we again go to stat. And this time we want to go up here to calculate. And we have choices, and you have to look at the picture and decide if a straight line, linear regression is best fit. A quad regression, remember we talked about endpoint or end behavior of graphs. Quads are even, so they both go in the same direction. And cubics are odds, the ends go in opposite directions. Quartics go in the same direction again. We'll try the easiest one that goes in the same direction, which is number 5, a quad regression. Now, not all of your calculators, once you hit quadreg, will look like this. It doesn't matter. If yours looks a little bit different, it'll ask you where's your X list, and you have to tell it it's in L1. If your calculator does look like this, you just type in L1 like that, second, number 1. If your calculator asks for a Y list, you type in the L2. If it doesn't, and it looks like mine does, you hit a comma, and you tell it where your Y stuff is. And then finally, we'd like to save our equation. That's what this third spot is for. And we want to save the equation where we can get a graph out of it. So I've hit variables. I'm going to go up here to Y variables. I'm going to look at the function variables. I didn't do a very good job of that. There's the function variables, and there's Y1. So what this says is perform a quadratic regression on my X values in L1, my Y values in L2, and store it in Y1. Then I execute it. And so there's my equation. You see it's in the form ax squared plus bx plus c. I asked for a quad regression. It gave me a quadratic answer. My a value is negative 16 with some decimal stuff behind it, x squared. Then plus 64.37x. And then my c value is about 80, 79 point something. This r squared value tells you if you have a good fit or not. And in general, the closer that r squared is to 1, the better your fit is if you are comparing fits of your lines or your equation, your model, to your data. Now what's cool about it is because we told it to save everything in y1, there is y1 when I hit the y equals. There's the equation already typed in for me, so I didn't have to do that. I can just hit graph. And what we're looking for is a line or curve that goes through most of the data points. And boy, that is a really nice fit. So there's my equation. If I need to pull that up, there's two ways to look at it. I can go back to y equals negative 16.13 x squared plus 64.37 x plus 79.8. So ax squared plus bx plus c. You could hit second quit. It's back here on your home screen still. So that's part B, find the equation. When will the height of the ball be 150 feet? A couple ways you can do this. One is, let's find the max height of the ball. So I hit second and calculate above trace. And I'm going to choose number 4, maximum. This has a highest point to it. When I choose that, it asks me for a left boundary. That just means put me on a left side of where you think the max is. So I'm arrowing over from the highest point. Hit enter. It says where's the right side of that, right boundary. And so I arrow over to the right side. I hit enter. If you can tell, it's giving me two little dark arrows here saying, hey, somewhere in between these two arrows is your maximum. Those are the points that I selected. They ask for a guess. So I'm going to try and move my cursor back to what I think is the highest point. Now hit enter. Now if you think about this, this is a ball being thrown in the air. And it says its maximum y value, remember y is our height, is 144, 143.9. Question was, when will it be 150 feet? It never will be. It does not get that high. Okay, so that's one way to find the max height. But even more specifically, we can do this. I'm going to hit y equals. I'm going to graph another line. Remember, the y is my height. So I'm going to ask, when is height equal to 150? I'll hit graph again. And so this line comes across top. That's the mark of 150 feet in the air. And you can see the football never gets up there. So it does not reach that as a max height. This is a big clue on how to answer D here. When will it reach 100 feet? I'm going to hit y equals and tell it to graph a line at 100 feet. So I've gone down to y2, typed in 100, and I hit graph again. So there's my points, there's my curve, that's y1. Here comes y2. And what you'll notice is that y2 here crosses my parabola right there and right there. This is the 100-foot height mark, and my parabola hits it twice. Now we can find this point of intersection and this point of intersection pretty easily. We can do calculations, second calc, and we can see where we found maximum. Underneath it is where's the intersection, number 5. So I choose that. First question again, what's the first curve? The first curve means, hey, if you're looking for two lines that intersect, tell me what one of the lines is. Which one is it? You could have 7 on here, and I need to know which ones you're talking about. Well, this is line y1, that's my first line. When I hit enter, it jumps immediately to the other one and says, is that your second curve? Yep, that's my second line. And it says guess. That means guess where they intersect. So I'm going to move my mouse or my cursor all the way to the left. So I think they cross right there. I know that crosshair, I just want you to find it exactly. And I hit enter, and it does some calculating, and it says, hey, the intersection point at 100 feet occurs when x is 3.44 or 3.437. Remember, x is time. This ball is 100 feet high after 0.3437 seconds. Then it goes higher. Let's find this point over here. I'll go second calc. I'll tell it to find number 5, point of intersection. It asks me for my first curve again, which is still the parabola. My second curve, which is still the straight line at 100, but now my guess changes. I want to guess over here is the point of intersection. And this just tells the computer which one you're looking for, essentially. So I move my cursor over there, I hit enter, and it says, hey, you're at 100 feet after 3.646 seconds. So I can answer that there's 2 spots that it hits 100 feet. Right there, I would have recorded that time, and right there. Question E, when is it higher than 100 feet? Well, any time between those 2 values that I just found, you can see that it's higher at that point. When will it be at a height of 40 feet? Same type of question, you just have to change your 100 to 40. Take a look at that really quick. That graph. Remember, my line was up here. Now 40 is going to be much lower. And right there it's at 40. It has a second point way over to the left, but that's negative time. And so that's not a valuable point. But this is the point we're looking for. You can do second calc, tell it to find that point of intersection and go looking for it. And finally, G, when will the ball hit the ground? And I will again just hit y equals. My ground height is 0. So I'm not going to put in 40, I'm going to put in 0 for that line. And I hit graph. Here's my parabola and my points again. And I don't see a line for y equals 0. Well, if you remember back here at our window, our y min is at 27, so we don't quite see it. I'm going to change that window. I'm going to make it go to maybe -1. And I hit graph again. Now I can see my x-axis in my picture, and hopefully I probably can't see the line y equals 0 because it's way down there, so I'm going to do something else. I'll make my line y equals 0 really thick. I'm just arrowing over to this section right here. And we'll hit the graph again, see if we can see that thing come in. Still don't see it. Well, I'll just zoom out a little bit then. I'll hit 3. See my cursor there? I have to hit enter again to get it to come zoom and zoom out. So I'm just going to kind of put it in the center of the parabola. So there's my points. There's that parabola coming through. And hopefully there's the line y equals 0. And now I'd find this point of intersection right there. I just go second calc. Find number 5 intersection. First curve, that's y1, my parabola. Second curve, y equals 0. And my guess, I'm going to move my cursor right there. And I'll hit enter. And it tells me the height is 0 at 4.98 seconds. And I've solved the problem. So that's kind of a graphical method that you can use with your calculators to analyze data, find that equation. Remember, that's the important thing, because the equation now can be used to predict future events, past events, and events that aren't shown in our table. For example, I know how high it is at 2 seconds, but let me hit zoom 9 here again. I know how high the ball is at 2 seconds, but what about 2.1 seconds or 2.2 seconds? If I hit trace, I can type in 2.2, trace again. Make sure I'm in trace mode. Oh, Trey says I'm the wrong equation. I'm up here on P1, my points. Arrow down, I'm on the equation. 2.2 seconds, there we go. And it tells me it's 143.3 feet high. I can type in 4 seconds. Tells me it's 79 feet high. Even gives you a flashing dot to say, hey, this is how high it is. 4.5 seconds. And I get 42.69. Notice it doesn't completely fit the data table, and that's alright. This curve is calculated and isn't going to match exactly experimental data. Hope that helps you guys. If you got questions, of course, see me in class.